So in this video we're going to talk about scale factors, and scale factors are really one of the fundamental ideas in maths. If you can get the ideas to do with scale factors right, suddenly percentage problems become very easy. It helps you with geometry and trigonometry, lots of applications in finance, all sorts of other things. So this is an area you really want to get right. So let's start with some percentage problems. So if I said what is 60% of 30, well, we could say well, 60% actually is a scale factor, if you like. We could convert it to a decimal, say. I could say 60% is 60 over 100, or 0.6. And to work out 60% of 30, we can do 30 times 0.6 multiplied by that scale factor and get 18. So the scale factor here I'm really thinking of is 0.6. I've converted the percentage to a scale factor. You could think of the percentage itself as a scale factor as well, and multiplied it by the amount, and that's given us the new value, which is 18. Now you could have done this in other ways. You might have said, well, if to get 60% of 30, I could have said, well, 10%, that would be just equal to 3, so 60% is 6 times that, that's 18, that gets you there as well. But this method we're building up is going to be really very useful in harder examples. So, for example, if I said what's 52% of 147, well, again, you could work out 1% and multiply it by 52, I suppose, but quicker, I think, to say, well, 52% corresponds to a scale factor of 0.52, and say, okay, it's 147 times 0.52. You can put that in your calculator or do the multiplication, and that gives you 76.44. Okay, so I'd better get on to showing you why these scale factors make things so much easier. Here's another problem. Increase 300,000 by 15%. I put a line down the page here because I'm going to do it in two different ways to show you how much more efficient the scale factors can be. Now, a common way students would go about this would be to say, okay, well, 15% of 300,000 is 300,000 times 0.15, which gives you 45,000. So there's a scale factor in use here, 0.15, but not used as efficiently as it might be. And then I'm just going to add that on to 300,000, and that gives me 345,000. And that's the correct answer. That's the original amount plus an extra 15%. We could, of course, instead of converting it to the scale factor of 0.15, have said, okay, well, if I'm increasing by 15%, what I'm essentially saying is I've got 100% to start off with, and I'm adding on another 15%, and that's going to give me 115%. So the overall scale factor, if you like, is 1.15. So I could have just said 300,000 times 1.15 and worked that out and got 345,000 directly. I suppose I should give these units if they're my final answers. Another scale factor here has been quite useful, although you might say, well, okay, well, you had to do an addition and a multiplication here, and here you did a multiplication and then an addition, so they're quite similar. But this sort of argument really is very powerful and efficient. If I say, change this question to increase 300,000 pounds by 15% 3 times, so maybe I've got something that's increasing by 15% each year, because here 300,000 times 0.15, this argument, okay, if I want to add on 15% again, well, I can't just add on £45,000 again, because it's not 15% of £300,000 anymore, it's 15% of £345,000. So I'd have to say, oh, okay, well, £345,000 times 0.15, that's 51,750, and now add that on to 345,000, which gives me 396,750. and now I've got to do it again, so I've got to say 396,750 times 0.15 is this time 59,512.5, and now I'm going to add that on to 396,750, which gives a final answer of 456,262.50. Okay, so it's quite a long-winded method in a way, whereas using this direct scale factor method here, where I just say, okay, we'll offer an increase of 15%, that's a scale factor of 1.15, all I've got to do is take 345,000 and times it by 1.15 again, and take whatever the answer there is and multiply it by 1.15 again. So I don't need to know any of these intermediary steps along the way, really. I could just say, well, the overall answer is just 300,000 times 1.15 times 1.15 times 1.15, which of course gives me the same answer as before, £456,262.50, but it's done so in a much more efficient way. So that's the power of scale factors and using them in neat ways. So that's the method we're going to use from now on. So let's just look at a few slightly simpler examples now. So if I want to reduce 75% by 18%, well, overall that's going to leave me with 82% left, so the scale factor is going to be 0.82, so I just need to do 75 times 0.82, and that gives me £61.50. Doesn't just have to be amounts of money, it could be any sort of number scaling up. So increase distance 1.75 kilometers by 72%. Well, I'm going to have 172% in total if it's an increase of 72%. So the scale factor is 1.72. So we take my 1.75 kilometers, multiply it by scale factor of 1.72, and that gives me 3.01 kilometers. Here's another problem. If I increase £100 by 25% and then decrease the result by 25%, what do you get? Well, you might say, well, it's an increase of 25% and then a decrease of 25%, so they cancel out, but that turns out to be incorrect, actually. Let's look at why. So if we have an increase of 25%, that's a scale factor of 1.25, and a decrease of 25% is a scale factor of 0.75. So I do 100 times 1.25 to increase it by 25% and get 125. And then I do 125 times 0.75, and if you work that out, you get 93.75, which is a bit less than what we started off with £100. And if you like, you could think about that as if we took that original £100 and split it into 4 equal pieces of 25. When I increase that by 25%, well, I get an extra 25, and then if I decrease the result by 25%, well, if I'm taking a quarter of what's here away, well, actually I've got these 4 black squares here, so I could just sort of take one of them away, but I'm also taking away a quarter of this 25 square, which accounts for that extra 6 1/4 that's gone missing. So when I increase by 25%, it was 25% of 100, but when I decreased by 25%, it was 25% of 125. So the actual amount of the decrease was lower, even though the percentage was the same. So the last thing we should just look at then is how to find the scale factor if we're just given the value. So here, let's say 125 has increased to 175. So 125 times something times x here has given us 175. So we've got 125 x equals 175. So x would be 175 divided by 125, which is 7/5 or 1.4. So that would have been that's an increase of 40%, if you like. 1.4 is an increase of 40%. So this is true in general, that the scale factor is the new value divided by the old value. So we've taken 175 divided by 125, and that will always work. Now, new and old don't necessarily mean new and old in terms of time, and depending on the problem, it might have been, it might be that it was a previous price and a current price, or it might just be a length in one shape and a length in another shape that we're thinking of as the new and the old value. But this is worth remembering that to work out the scale factor, you just take the new value and divide it by the old value. One last example of that. Let's say we had 80 has been decreased to 64, and we want to work out what scale factor, what percentage that is. Well, we'll just do new value divided by old value, and that gives us 64 divided by 80, which simplifies down to 4/5 or 0.8. So that would have been a decrease of 20%.